everyone. This is part 2 of module versus packages. We just looked at what is a Python module. A Python module may contain several functions, classes, variables which we have looked into in the last video. Now, if you look at packages is just nothing but it's an extended or a bigger version of a module where package contains different modules itself in it. So when you look at a module, the way we accessed it in the last video is you try to import the module name with the import key, and then you use the module name dot the functions and supplied values to it. Now in packages, what happens is in package you have different sub packages also sometimes, or you have different modules which is going to be organized in a well manner. Okay, so in this particular example which has been shown on the screen, for example, if you're going to create a package called as a game has different entities itself. So you have sound, you have images, you have different levels to clear and so on. So if you look at a package has different sub packages or different sections of modules in it. It's going to contain different modules in it. So this is one of the examples which has been shown. But if you look at the hierarchy, the directory system over here, it starts with something called as init.py. That's a separate file which we are going to create, and this file is nothing but it acts like a initialization process, the startup process for a package. So the package itself is contained with a lot of details of data. So when you're executing it, you need to initialize the package, or you need to tell the Python compiler from where you need to start. The Python compiler runs into the init.py file, and then it gets data from there and it starts executing the instructions. So the init method over here, or the init keyword which is going to be used over here, is going to help us to initialize or to set a startup for the entire Python project or the Python package which we are looking at. The next is sub packages. Now when you're creating a sub package, if it's a package, then you have to require the init.py file in it. Otherwise, if you're creating a module, the module can be created like I've shown in the previous videos. Only if you're creating a sub packages, then you require the init.py file. Now let us look into how to create a package. So in my example over here, I'm going to name the package itself as my pack, the short form I've given, and that in turn will contain two modules, module 1 and module 2. So mod 1 and mod 2 is my module name. My package name, the entire package is going to be my pack. Now in this module, we are going to create a folder, the regular folder, the normal folder, how you create it on Windows. We're going to create that as my pack, and I'm going to have two files, which is the Python files, which is mod 1, mod 2. Apart from that, I have to create an empty Python file, which is _init_.py. So there are going to be 3 different .py files inside my folder called as my pack. So this is how it's going to look like. So you're going to have init, this is a regular file, the mod 1 and the mod 2. We'll come to the D file which is created later on by me, but right now according to the folder, inside my folder, I have named my folder my pack, and inside that I have 3 files, which is init, mod 1. Now the procedure for creating a package, I've told you, you're going to create folders, and inside the folders you have 3 Python files, which is going to be the init file, and you're going to have the 2 files, which is mod 1 and mod 2. So apart from that, you're going to check something called as a path. So to check which path you need to add to, because the package itself is going to be a heavy file, and you need to place this particular package, that's the folder, inside the Python path. During installation, your Python would have been set, or you would have executed the instruction, the executable file would have gone and sat in one particular directory. So you need to check that out, and you need to place this folder, that is my pack folder, inside that particular path. Only then when you execute it will the package act like a package or a separate entity which you can keep accessing it for your project work. So because of that, you need to check the path. So to check the path, we are going to use a particular variable or the particular constant where it will help us to check our path. Otherwise, you need to keep running into different folders, and you need to keep checking where your Python file has been installed. So it is going to be far easier if you know the path and you can place this folder directly into the path. So when you're making the folder, you can make it on the desktop for now, and then later you can pick it up and you can place it inside the path. Now my file or the folder is already placed inside the path. You can also directly go and create it inside the path. So to check the path, we are going to see how we are going to run this command to check the path to place our folder. So I'm going to use Python So you're going to import a module called as sys, and you're going to print sys.path. So when you click on, when you hit the enter for this particular command, you will know that the Python file has been kept inside the C drive under user, and this is my folder name, and inside the folder name there is app data. So what you have to do is you have to literally figure out, or you need to run through the hierarchy, and you need to open this file and reach the library, the lib folder. So once you reach the lib folder, then you will be able to open that. So go to your C drive, open the folder user. This is my name. Just check what happens in your computer, and you need to trace the path and keep it open till lib. Now you have to move that package which is there on your desktop with my pack package as a folder. The folder contains 3 files for now, that is the init.py, mod1.py, mod2.py, right? So it has 3 files. So with that, we are going to, okay, now with that, move into the folder, open mod1.py. Right now it's empty, so let's code in this. I'm going to code a function definition, that is a simple definition saying welcome to packages, and open mod2 as you see on my screen, and you're going to have another function called as sum a, b, which I've copied it from the modules function itself, the function definition. So once you're done with this, mod1 and mod2.py is done, and it's ready for execution. So you can run it separately and keep it, compile it separately and keep it. Now this is the py file. Now the py file can be left blank, or it can have import functions from the module. Okay, you can import those mod1, mod2, and you can say mod1.fn, mod2.sum. So you can import it into the init file. Now right now init file is empty. So if you want, you can have this also written. So right now I have in my init file from .mod1 import fn, from .mod2 import sum. So I have this as the content of my init content. Now the next step for me, what I'm going to do is I'm going to have another Python file which I have named as a D. Okay, D is going to be my main program where I'm going to code. So right now in the library folder, I have the folder called as my pack, and inside my pack, don't worry about this. When you start executing, this is the folder which is going to be created for cache. My package right now has the init file, the mod1, mod2, and right now I'm creating the D file, which will help me to enter into it's going to be a main program which will help me to enter into the packages. This is what we have seen. So this is my system path, which we have just checked. You can check it again if you have a problem. Let's open the D file, the d.py file in the script mode, and then you can import the packages. Now I'm going to import the complete package, saying that from my package import star, or you can say import mod1, because I have only one function, so I have imported mod1, and from my pack import mod2, or you can say from import my package once for all, and then you can start using. The module 1 has only one function, that is fn, but module 2 has some function where I have to pass 1 and 2. So once you finish this, you can print whatever the res variable captures, because in mod 2 I have a function which is sum. If you see here, it's going to return the value of a plus b. So once you finish that, okay, so once you finish your D part, I've kept all my mod 1, mod 2, the init file and the D file open. So what you need to do is you just have to compile the D file to see. Now what happens is this is going to create a package. Okay, so the package contains different modules in it. So in your projects also you can have different modules. So you can have module 1, module 2, or if you're doing a group project, you will be asking one person to compile something, the other person to compile something. So it can be done as a menu driven program, and you can access these different modules and make it more flexible. So when you run this, you will be able to see that it is because when I am executing, I am going to, in one of the functions, I have printed the sys.path. That is why this entire stuff gets printed. Otherwise, this is from function 1, that is from module 1, and this 3 is getting returned from your mod 2, that is the sum function. So this is how you create your packages with the init function, which is going to initialize and create the it's going to compile it as module inside a package. So module 1, module 2 is being packed inside the package. Then you have the mod 1, which is going to be acting with one function. Then you have the mod 2, which is having the second function, and after which I created the last compiled program, where this is going to be my main program, where I can import the package, that is import star I have done. That is, I'm going to import everything from that particular folder called as package, that is both my modules, and I can access it. This you can remove it, you don't have to keep printing it. You need this sys.path only to place the folder. All these files which are going to be saved as a Windows folder, that folder has to be kept inside this particular Python file. So inside wherever the Python file has been installed, it is always installed under programs in the C section. So programs under C section will contain Python. Now Python, I have 3 different types of Python. This is Python 9 point some version, where 3.9 version, sorry, and I have 3.8 and I have 10 version also. So inside that particular Python file, there is a file which is called as library. Now inside that, I am going to place my folder, copy the folder, pick it up from your desktop if you're working on it separately first, and then place it into this folder. Now once you compile that folder, you will be able to, when you initialize this, your init file will create a file which is py cache file, which is nothing but it is a system file from the program library. So you don't have to worry about that. So you, at the end of it, it has to create that py cache file, but you don't have to worry. But right now in the initial state, to summarize, I have the init, mod 1, mod 2, after which you are going to create the D file. So this entire setup acts like a package, and you have got your packages ready. So you can convert your entire program or a project into packages.